All right, this is the review for your quiz on completing the square. Some of these problems are easier than others. This one is really designed to be a relatively basic completing the square problem. It is given to you slightly differently. Normally you would see this written in a standard form where the x squared is first. In this case, they're both positive and they're both on the same side of the equation. So you can simply reverse where they're located and keep the signs the same. So actually this is just x squared plus 14x, and then I'm going to leave a space there and put 0.4. The whole idea out of all of these completed square problems is you really want to figure out what number would go in here that could allow you to complete the square, and then go factoring it. So in this case, completing the square is b over 2 squared. And the b is the number that is next to the x term, so in this case it is 14 over 2 squared. 14 over 2 is 7, and when I square it I get 49. So what I'm really going to do here is add a 49 in on the left side, and I have to add it to the right side. So I have to deal with x squared plus 14x plus 49 equals 73. So in this case then, to actually do the factoring part of it, I break it up into, because it's now a perfect square trinomial, I'll factor it like this, where I use the square root of the first term, the sine of the middle term, and the square root of the third term. So at this point, I'm ready to really start solving it all the way down. I've gotten it to be a little simpler. Now I'm going to get rid of this square here, so I'm going to square root this whole thing, and I have to do both sides. So the square root and the square wipe each other out, and I'm left with x plus 7 equals plus or minus, because we do that with all of them, the square root of 73. Okay, so I'm almost done. Basically now I just want this plus 7 to go away, so I'm going to subtract it away from both sides, leaving me with just the x. Okay, I have a situation over here. I have something with a square root and something without. I can't put them together, so the best I can do is write the regular number first, and then I'll write plus or minus the square root of 73. When I get to this point, I always have to check whether or not this square root can be simplified, that is, split into maybe a perfect square and something else. In this case, it cannot, so this is the final answer to this problem. Okay, let's take a look at number 2. This time, number 2 actually has a number in here that is an easy square root. So I'm thinking, well, maybe that's the number I actually want there. So if I look at it, the only way to know for sure is if I use b over 2, what I would normally use to complete the square. Well, I'm going to use it this time as a way to check to see if that's the right number in there. So when I get negative 14 over 2, that's negative 7. So when I square it, I get 49. That tells me that the number that's supposed to be here should be 49, and it is. So I don't actually have to go through the step of adding a number in, and I have the right one there. So it is perfectly fine as it is. So I can go ahead and factor this. Square root of this, the sine of the middle one, and square root of that. So again, I'm ready to get rid of this square, so I can square root this side and this side. Those square root and square cancel. I'm left with x minus 7 equals plus or minus square root of 18. Now I'm going to add the 7 to the other side so that I can get x by itself. I have 7 plus or minus the square root of 18. Just the same way I did the last problem. The only thing is, this time, this square root of 18 can actually be separated. So I need to do that. Everything else is going to stay the same. But this square root of 18 is going to split up into 9 times 2. So when I do the square root of 9, I get a regular 3, and I have the square root of 2 left over. So it is this that is the final absolute answer to it. Simplified and all. All right, let's take a look at number 3. It's a little different than the others. Number 3 is actually what I would call an example of an easy solution. It doesn't require the perfect square. It doesn't require completing the square. None of that stuff. The reason that is that there's no x term in here. It's still a quadratic because it has an x squared, but there's no middle x term anywhere in this problem, so I don't really have to worry about it. I can just try to isolate the x out of this. So I would add 6 to both sides. Now I'm down to 2x squared equals 48. Then I would divide everything by 2. Now I'm just to x squared equals 24. And like any other square root, or excuse me, square, I'd want to get rid of it by square rooting so that that cancels. Now I'm left with x equals plus or minus square root of 24. And one thing about that is, again, the 24 would split up. So everything stays the same. So that 24 will split into 4 times 6. So my final answer is 2 square root of 6. So when number 3 was easy, number 4 is more of a pain. It isn't really hard, so to speak, in terms of being something different. It's just a matter of the numbers you're going to have to deal with. So first thing, I try to find a common factor. I don't have any because there's nothing here to divide away, so no greatest common factor. But I do need the x terms together, so this 3x has to go to the other side. So I have x squared minus 3x equals 4. All right, it's basically, I'm just going to click back here for a second. It is basically very much like how we started this problem. In fact, better yet, it's more like this problem right here, where we had a missing value in here that we had to come up with. So we're kind of back to that position again. As you can see, there's no value in here. So I have to complete the square. The only problem is this time b is negative 3. So when I square this, this is not a nice easy number. But I should leave it as a fraction, no decimal. So this would be 9 over 4. That means I got to add a 9 over 4 on this side and on this side. So I've got x squared minus 3x plus 9 over 4 equals. Okay, the issue is, what is this equal? What I'm doing, and I'm just going to do this on the side for you real quick, is 4 plus 9 over 4. And remember that 4 is like 4 over 1. But to add two fractions together, the bases have to be alike. So for this to be over 4, I need to multiply this whole thing by 4. So I'm not going to use 4 over 1, I'm actually going to use 16 over 4. And when I add that together, I get 25 over 4. So this outside number out here, right here, is really 25 over 4. So you can see it makes it a little bit more of a pain just because there are fractions involved. If it wasn't for that, it's basically the exact same story. So now you're ready to factor it like we would have before. I'm going to get square root is x, the sign is minus, and the square root of 9 over 4 is 3 over 2. That's why you leave it as a fraction. Okay, now we're looking to get rid of this square, so we'll square root all of this and the other side. That cancels. We've got x minus 3 over 2 plus or minus over here. Now, square root of 25 is 5. Square root of 4 is 2. So actually, even though we have fractions, we end up seeing no more square roots in the whole problem. This becomes a little bit of a mess because we are still working with fractions, but we're going to add the 3 over 2 to both sides. And I get x equals 3 over 2 plus or minus 5 over 2. Okay, what this means is that you actually have two solutions here. One of them is going to be 3 over 2 plus 5 over 2, which is 8 over 2, and that's equal to 4. And the other solution is 3 over 2 minus 5 over 2, which is negative 2 over 2. And that is equal to negative 1. So you kind of have to watch when you deal with the fractions, or even if you get a regular number here that isn't a fraction. This plus or minus thing means you actually do two simple, small problems. 3 over 2 plus 5 over 2, and 3 over 2 minus 5 over 2, which is this one. So these are your two answers to this one. So believe it or not, out of all of that work, with fractions and everything, you actually end up with two pretty easy numbers as answers. Okay, this time we have a problem that's got what looks to be like a whole bunch of stuff going on in it. You can approach it a couple of different ways. My suggestion would be to divide everything by 4 so that this goes to be an x squared, 8x, and 4 equals 0. So at least you got it down to a regular x squared. That's fine. Now, as far as this is concerned, normally we would want a number here. But the question is the number right? It's a perfect square, so it kind of makes you think maybe it is. But you got to check it to actually make sure it's right. So when we had that back here, this 49 that was here was actually the right number. We checked it using completing the square. That was correct. So we left it there and didn't do anything with it. This one, on the other hand, I think when you go to check using complete the square, it would be 8 over 2 squared. That's 4 squared, which is 16. It means this number is supposed to be a 16, not a plus 4. So to make it 16, I guess you can do it two ways. You could just add 12 to both sides. That would work. So let's do it like that. Or, you know what, we didn't do it in class like that. Let's make this number go over here. Seems like a little extra work, but it's okay. Now we have that blank that we're going to fill in. So the blank is actually 16. So I'm going to put a plus 16 in here. And I remember I have to add it to this. So it's actually negative 4, and then I'm going to add 16 to it. So it really isn't negative 4 at all. It's actually going to be 12. Okay, so I'm ready to factor now. The factoring is x, a plus, and a 4, 12 on this side. Ready to take out that square with a square root. Now I've got x plus 4 equals plus or minus square root of 12. Really, the only thing left is to get rid of the 4, so I'm going to subtract it off. Got that negative 4 in the front, plus or minus square root of 12. And the only thing left to check is if that square root of 12 can be split up. As it turns out, it can be. So I'm going to keep the same thing here, except it's going to be 12 is 4 and 3. So that's 2 square roots of 3. There's our final answer for that one. And finally, number 6, if you look at it again, there's no x term in here. I would call this one an easy problem. So we would subtract the 8. See how fast we can do these. That's 36. Then I'm going to divide by 3. That's 12, and I'm going to square root everything. That's plus or minus square root of 12. And because 12 can be split, we just did it on the last page. 12 splits into square plus or minus. And I have square root of 4, square root of 3. That's 2 square root of 3. Final answer. So really, this is going to be a pretty short quiz, as you can see. What I can guarantee that you're going to see is you'll see one of these easier solving problems. You'll see one like this where you have kind of a mess where you have to divide out a greatest common factor, find a complete the square, and do all that. You'll have one with fractions like this for sure. And you'll probably have one that actually works out the easier answers like this. So you're going to have one that involves fractions, one that works out the easy solution, one that works out to a simplifying square root, and one that works out overall as a pretty easy solving problem. That's it.